Alright, so I'm just doing another set of recursive equations here, or another single recursive equation. So this one is x element 1 is equal to 4, and x of n is equal to 3x, oops, what is it, 3x of n minus 1. That's it for n greater than 1. Cool, so this is our recursive equation to work with, and we just want to substitute out and find the answer. So just like the last one, the term we don't know here is x minus 1, so we're just going to sub that in here. So here we have x of n minus 1 is equal to 3x of n minus 2. And then just like last time, we're going to substitute this x minus 1 for that n minus 1. And so now we get x, x of n minus, sorry, it's late. X of n is equal to 3 times 3 x of n minus 2, because remember this 3x n minus 2 is just replacing that, so we've still got this 3 times out the front. So I guess if we wanted to simplify this, although we'll see it more clearly in a second, so now obviously we need to solve x of n minus 2, because that's the term we don't know, is equal to, 3x of n minus 3, because we're just substituting it back into this initial equation. And then just like last time, we're going to substitute in that x of n minus 2 for that x of n minus 2, and we get x of n is equal to 3, so this 3 stays here, dot, that 3 stays there, dot, and now we substitute this in, 3x of n minus 3. And kind of once again we're seeing a pattern emerge here. So here essentially what we've got is 3 squared x n minus 2, obviously 3 times 3, 3 squared, and here we've got 3 cubed x of n minus 3. And so naturally again we're kind of getting this pattern emerge where we've got 2, 2, 3, 3, and so that's kind of the pattern that we can work with. So we want to say, okay, for any value of x of n is equal to 3 to the power I x of n minus I. And again, the only important property of I here is that I is a constant. That I is constant between these 2 points, that I is the same value in both of those cases. I really has no other properties. So again, we want to make I something that lets x of n minus I equal 1, and so we're going to do the exact same thing for the same reason. We're going to let I equal n minus 1, so that n minus I is going to equal n minus 1, which is going to give us 1, which is what we want. So substituting that back in over here, we've got x of n is equal to 3 to the power of n minus 1 times x of 1. And we know that x of 1 is 4. So we have our final result, x of n is equal to 4 times 3 to the power of n minus 1. And that's as far as we can simplify this. So again, just like what I said in the in-between video, this is now the explicit version of this recursive definition of this arithmetic sequence. So this, if you plug in 50 here, and you actually write this as a programming function, the answer is going to be the same as if you plug in 50 here. That will give the same result. This is not calculating its cost or efficiency. This is a conversion of the recursive function to an explicit function, although that is the same way that we kind of deal with recursive functions in general.